72 divided by 3 squared times 2 divided by whole divided by 6. This is a fraction bar. So what I will do, what you will do right now in the first step.
I redid it actually, and I got 3.
Okay. So was that the right answer, or should I check it?
Maybe we should check it because I just wanted to make sure.
Okay, 1 second. We're having open the book. All right. So it was section 2.2, question number 3. Is it section 2.2? I'll check it again. So what was the answer to the question number 1?
10.
10? Oh, I'm checking chapter 2. I'm sorry. Chapter 1, answer key. Okay. So question number 1 was 10, and question number 3, how much you got?
I got 3.
I think we need to do it again. Maybe it's perhaps 8 divided by 3. Let us check it. So what you did, like what was the step you did after this?
So do you want me to like do it again and then tell you my steps as I go?
Yes, right, correct.
Okay, so first I did the exponent, 3 to the second power, and that's 9.
Okay.
So then 72 divided by 9.
Okay.
2.
Okay.
Over 6.
So how much is 72 divided by 9?
8.
8 times 2 over 6. So after that,
That's 8 times 2 is 16.
divided by 6, and then?
Yeah. And then isn't it like 16 divided by 6?
Yeah, right.
Which would be, hold on. So 2, 4 over 6.
4 over 6.
Yes.
How?
No, 2 and then 4 over 6.
Oh, 2 and then 4 over 6, right?
Yes.
Correct. So can you make it an improper fraction?
So wouldn't it be 16 over 6?
Yes, can you simplify it a little bit? Like 2 times 3 is 6 and 2 times 8 is 16, right?
So 8 over 3?
Yes, and that was the answer. So how did you got only 3?
I don't know. I did something wrong, obviously.
But you're right, like your steps are right, and you got the right answer right now. So definitely I will consider this as a right answer, as you did it perfectly, as it has to be done. So it is question number 3, and then you're having question number 5. Right, so can you
I
do
got
this?
62.
Okay, 62 for question number 5. Question number 5, 62. We need to rethink about it. What there's a mistake perhaps. So 2c divided by a whole squared minus 10 times b plus a is in parentheses divided by c. So you plugged in you plugged in the numbers and then you try to solve. So tell me, like, what is the next step after solving? Like, after plugging in, what was the next step?
Okay, I'm going to redo it on scrap paper because I have
Okay.
no more space on my other scrap paper.
Okay, sure.
So let me fill these in. 5 over -2 squared minus, yeah. Okay, so first I would do 3 plus -2,
Okay,
which would be 1.
right,
So then that would change to 10 times 1 over 5.
right,
And everything else would stay the same.
correct.
And then 10 times 1 is 10, divided by 5 is 2.
Mhm.
Then I'm going to work on this over here.
So this will be 2 here on the right side, right?
Yes.
Okay.
Okay, would that be -5?
-5 on the left
Yes.
side.
Yes.
Before going for -5, can you tell me if we square -1, how much we'll get?
-1, or no, +1.
Exactly, because when you're squaring a negative number, you're always getting it positive, because squaring means you're doing it -1 times -1. So
Yeah.
negative times negative will be positive. So it'll be +1. In the same way, if you're having some negative number inside parentheses and there's a square and you square it, then definitely that negative number is gonna be positive, right?
Yes.
So 2
Okay.
times 5 is 10. 10 divided by -2 will be how much?
5.
10 divided by -5. So -5 whole squared is how much?
So isn't that 25 minus 2?
Yes. So how much is this?
23.
Correct. So that is the answer.
Okay. Now I see where I went wrong.
Where?
Where I went wrong.
Yeah, where did you went wrong? Like a negative part?
Yes.
Okay, okay.
And I
Yeah.
redid 7.
Oh, okay. That means that was a small mistake which can be avoided. Okay, so let's go to question number 7. So plugging in the numbers, can you tell me
I
what?
redid it.
Okay, what was the answer?
42.
42, that's correct.
Yes.
So beautiful. I think this is one of the difficult questions in these 8 questions, and you have done this perfectly right. So I don't think there'll be any problem in doing the order of operations for these types of questions. Now let's go to the next concept. Let's talk about the numbers, because we should be very clear about different types of numbers and how to tackle with them, and any question which comes related with those numbers, we should not be having any type of confusion. So I'll go a little bit back. Okay. So before going for numbers and solving for expressions, what I want to do is I want to understand what really a term is in mathematics. A term, there's a term in English, it's called something, and there's an explanation for that term. In the same way, in mathematics, there are terms, and the terms are connected with multiplication or division. Remember this. For example, 2 times 3, it is one term. It's a term. 72, 7 times 5 times x, or you can say 7 times 5 is 35 times x means 35x. It is one term. So if you put in these terms together, for example, 35x plus 6, now you're having two terms, 1 and 2. This is the first term, this is the second term. So we're combining the terms. Now, how can we say two terms are same or two terms are different? You have to check two things. Remember, two things for checking whether the term is same or whether the term is different. And why do you want to know why the term is same or different? Because if you're having same terms, then you can add or subtract them. If you're having different terms, then you cannot add or subtract them. For example, 7 bananas minus 6 oranges, right? So I can say that we can't subtract. We can say that 7 bananas minus 6 oranges will be 1 pineapple. No, it's not possible, right? Because they are different terms. Are you following what I'm saying?
Yes.
In the same way, 35x plus 6, 35x is a different term and 6 is a different term. They're not same. So that's why we cannot combine them. So they will remain as they are, 35x plus 6. We cannot add them. So two things we have to see for checking whether the terms can be combined or not, whether they are different or same. Number one, they should have the same variable or variables. And number two, the power on the variable should be same. Power on variable should be same. For example, 22 bananas plus 7 bananas. So what do you say about 22b and 7b? Are these terms same or different?
Same.
Same, because their variable, that's a banana, that's b, is same. B is here also and B is there also. And the power on the B, you can say that 1, because whenever you don't write anything, it's 1 there. So the power on B is also 1 and 1. So we can say that these two terms are same. So we can combine them. 22 plus 7 means 29 bananas. Are you following?
Yes.
Now, if you're having 32 x squared plus 27 x squared, what do you say about them?
They are the same.
Why?
Because the variables and they're both squared.
Yes, because the variables are same and the power on the variable is same, so you can combine them. 32 plus 27 is how much? 59x squared.
Yeah, 59.
Okay. What about 2xy plus 3yx?
They're different
Why?
because the variables are in different orders.
Different orders. Okay, what about 2 times 3 and 3 times 2? Is there difference in them?
Well, technically they're the same thing, right?
Yes, exactly. Technically, they're same. So if you write x times y or y times x, you're just using the commutative property. You're just changing their position, but still the answer will be same. 2 times x times y plus 3 times y times x. You can write that also as 3 times x times y. No problem in it. Because variables follow commutative property, you can commute to them. You're moving from your home to school and school to home, right? So it's the same way. You're taking x to y and y to x, no problem in that. In multiplication, right? In multiplication, you can just change the order, like 2 times x times y. You can write as x times 2 times y, no problem. Because 2 times 3 times 4 is same as 4 times 3 times 2, right?
Right.
That's why we'll say that these two terms, 2xy and 3yx, they are same, right?
Yes.
So it'll be how much?
That would be 5.
Yes, 5xy or yx, whatever you want, no problem in that. So this is, same terms. What about 2xy squared plus 3x squared y?
Isn't that the same thing as well?
Two things. Check for two things, which I have told.
Okay, so that's not the same.
Yes, that's not the same because the variables should be same. Okay, variables are same, x is x and y, but the power on the variable is different. In the first term, we're having y squared. In the second term, we're having only y. In the first term, we're having x, and in the second term, we're having x squared. Powers are different, so these two terms are different. So you cannot combine them. You can write them as they are, that's it. 2xy squared plus 3x squared y, that's it. Is it clear till now?
Yes.
Okay, one more example. 7x plus 3y plus 3x minus 7y plus 2. Can you have any, are there any same terms, similar terms, which we can combine, solve?
7x and 3x.
Correct. Why?
Because their variables are both the same.
And
And
the power on the variable is same, right?
yes,
2
because
point,
they're both, wouldn't
yeah.
it be 1?
7x plus 3x. Huh, yeah, that's right. That's right. It's 1. X to the 1, x to the 1.
So that would be 10x.
Correct.
And then we can also combine 3y and 7y.
Because the variable is same and the power on the variable is same. That's
Yes.
1 and 1. So how much will it be? 3y minus 7y.
-4.
Negative 4y, correct. And then plus 2, right?
Yes.
Because 2 cannot be combined with these two terms because obviously 2 is not having any variable. So it is this expression consists of 3 terms. This is first, this is second, and this is third. Fine till now? Should we move forward? Like, is it okay till now?
Yes.
Okay. Okay, now let's go to some properties. As you know that 2, if that is multiplied with 3 plus 4, right? So obviously by using PEMDAS, what we have to do is we have to solve first what is in the parentheses. 3 plus 4, that's 7. And then you multiply it to 2, that's 14, right?
Right.
But what you can do is these numbers, these variables, in mathematics, we are having distributive property. We can distribute this 2. with this 3 and with this 4. We can multiply this 2 with 3 and 4. So what we can do is we can write 2 times 3 plus 2 times 4. We'll be still having the answer as 14. You can check 2 times 3 is 6, plus 2 times 4 is 8, and that is 14, right?
Pardon me?
Yeah. I can repeat this.
Yes, repeat what you just said, please.
Yeah, sure. So here we're having one example in which in parentheses we're having 3 plus 4, and this 3 plus 4 is multiplied with 2 at the end. So when you will do PEMDAS, this will be 2 times 3 plus 4 is 4, 5, 6, 7, and then when you will solve it, it'll be 14, right?
Right.
But what happens here, we can use this 2, we can distribute this 2 as we have, that 2 in multiplication with 3 plus 4. We can beforehand we can multiply this 2 with 3 and with this 4, which is called distributive property. We can distribute this 2 over multiplication, over addition, sorry. We can distribute this 2 over, multiplying this 2 with 3 and multiplying this 2 with 4 individually. 2 times 3 plus 2 times 4, because 2 is in multiplication with 3 plus 4. So that's why we can use the distributive property here to solve it. 2 times 3 plus 2 times 4. We can use the PEMDAS, there's no problem in that. But we're having one property for numbers, for variables, in which we can distribute that number which is outside parentheses. We can distribute that number. We can give this 2 to 3, and we can give this 2 to 4, because this 2 belongs to 3 as well as 4. It's not the property of only 3, or it's not the property of only 4. It belongs to both. So that's why we can distribute this 2. We can give this 2 to 3 also, and we can give this 2 to 4 also. But since it is in multiplication with 3 plus 4, that's why we'll multiply it with 3 and 4. 2 times 3 plus 2 times 4. Confusion?
No.
So how much is 2 times 3?
6.
And how much is 2 times 4?
8.
So how much will be total?
14.
So we got the right answer. Right?
Right.
Now, if we're having, instead of numbers, if you're having variables, for example, A times B plus C. So this A is not only to be multiplied with B or only to be multiplied with C. It is to be multiplied with both A times B plus A times C. So it'll be A times B plus A times C. Right?
Right.
Or if it is A times B minus C, so we'll multiply with this A with both A times B minus A times C. So this is called distributive property, which we have done. So if anywhere you're having this form, 3 times -2 plus 7, so what it will do there, in order to make it easier, you can use PEMDAS also, no doubt in that, but how can you use the distributive property to solve it?
So 3 times -2
Uh-huh.
and 3 times 7.
Correct. So 3 times -2 will be -6, and 3 times 7 will be 21. So -6 plus 21, and that'll be?
That will be 15.
Correct. Right. So this was distributive property, and we discussed about the commutative property, that if you're having 2 plus 3, that is same as 3 plus 2. If you're having 2 times 3, that is same as 3 times 2. If you're having x times y, that is same as y times x. Right?
Right.
And associative is extension of commutative. If you're having x times y times z, but x and y are in parentheses, you can change the parentheses. You can write x times y times z. The answer will still be same. If you're having 2 plus 3 plus 4, you can write as 2 plus 3 plus 4. The answer will still be same. So you are associating different partners, you're associating different numbers, and still you're getting the same answer. So when you get the same answer, you can say that they are following associative property. There's no problem in them. They're following associative property. So we are able to see that in multiplication, associative property is followed. In multiplication, associative property is followed. In addition, associative property is followed. Right?
Right.
Now, let us see some example. We're having option B. I'll just erase it here. I will write the question with the red ink on the left side. 4 times x cubed minus 2 times x cubed plus 3x. So we're having this question and we need to simplify it. So, well, 4 times x cubed is as it is. And now we can use the, distributive property here. -2 times x cubed is how much?
I'm sorry, I couldn't quite hear you.
Oh,
That last part that you said.
okay. So I wrote the question. Example 1, option B. 4 times x cubed minus 2 times x cubed plus 3x. So 4 times x cubed, I wrote it as it is. And then we're having -2 times x cubed. How much is that? Because I want to use the distributive property here. -2 times x
2x
cubed.
cubed.
How much?
2x cubed.
Yeah, but there'll be negative sign also, isn't it? Because you're having
Yes.
-2. So
Yes.
-2x cubed. And how much is -2 times positive 3x?
-6x.
Correct, -6x. Are we having, out of these 3 terms, are we having some same terms, like similar terms, which we can combine? Like terms, sorry. Are we having like terms which we can
Yes.
combine?
Yes.
Which one?
4x cubed and -2x cubed.
So how much will that be?
2x cubed.
Correct. And -6x, right?
Yes.
So this is the answer. So we did some simplification. Now, can you please do option C? Example 1, option C yourself right now.
Okay, give me 1 second.
Yep. I'll write again this question. A times 2 minus B minus 2 times A minus B.
Okay, so would that be 2a negative ab
2A negative AB, yeah.
minus 2a negative 2b?
Okay, negative 2 times negative B is how much?
Oh, it's a positive. I'm sorry.
Positive, right? Positive 2B. So any like term?
Yes,
Which one?
2a and negative 2a.
So how much will this be?
Wouldn't it just be a?
Okay, 2 bananas minus 2 bananas will be how many bananas?
0.
Exactly. So 2A minus 2A will be 0, so it's all over. We don't need to write this. And it'll be negative AB plus 2B. That is the answer.
Okay, I got it now.
Beautiful. This is example 1, part B and C. Now let's go to the questions. Because you had to do this a lot. You had to do this a lot in SAT as well as PSAT. So that's why we need to be very strong in this. Let us do question number 1 first, because this needs to be have more exercise, more questions, so that we can be more perfect in this. Can you read question number 1?
Okay. So, which of the following expressions is equivalent to 2 over 3 in parentheses a to the second power minus a minus 3 the parentheses plus 1/3 and then in parentheses again a to the second power plus 2a plus 6.
Yes. So I need you to do this. What you will do? First step.
Wouldn't that be 2 over 3
Mm-hmm.
to the second power?
2 over 3a to the second power, and then
2 over 3a
negative 2 over 3a.
and then negative 2 over 3.
Yeah, negative 2 over 3 times 3. So how much will it be? Okay, I'll write it as it is. Negative 2 over 3 times 3. And then after
That would be
this,
negative 2.
yeah, there'll be negative 2, correct. So after this,
Okay, and then plus 1 over 3 a to the second power,
okay,
1 over 3 times 2 a,
okay,
and then 1 over 3 times 6.
correct. Let us see, is there any like term?
Um, 2/3 a to the second power, and then 1/3 a to the second power.
Correct. So how much will it be? 2/3 plus 1/3.
Wouldn't that be 3a to the second power?
Can you repeat again what you said?
Would that be 1a to the second power?
Yes, 1/8 to the second power. You're right, because 2/3 plus 1/3, when you want to add the fractions, you will keep the denominators same. So there are already denominators, they're same. So it'll keep 3, and then 2 plus 1, that's 3/3, and that's 1. So 1/8 to the second power, you're correct. And we don't write 1 because, if it is x, it is actually 1x, but we don't write 1. So that's why we can write a squared simply. A to the second power, right?
Right.
Are you having any confusion in this addition of fractions?
No. I
So
just wanted to. I hesitated because I
mhm,
was nervous. So, like, my brain, I don't know,
mhm.
it does this thing when I'm nervous.
That's why I'm telling you that whenever you feel any little bit confusion anywhere, you will tell me clearly so that we can, clear that completely, and you'll be 100%, I mean to say, not nervous. I mean to say he'll be 100% satisfied in this, that I'm able to do that. So 2/3 a squared plus 1/3 a squared will be 3/3 a squared. That means 1 a squared. That means a squared. And then, are we having any more? Any more like terms?
So, we would most likely, wouldn't we have to multiply the fractions like 2/3 times, and then 1/3 times 6?
1/3. Yeah, right. We will do that. But yeah, we can do that. Tell me what to do. Okay, I'll write it again. A squared minus 2/3a. And then how much will it be? Negative 2/3 times 3? Negative 2
It
over
will be
3.
-2.
Yes, because negative 2/3 times 3 means negative 2/3 times 3/1. So you can simply say that 3 times 1, it'll be negative 2/1. That's -2. So it'll be -2. And we have already covered this. We have completed this. And we're having plus 1/3 times 2a. So can we write it as 2/3 times a? In order to keep the numbers as fractions. 1/3 times 2a. Can I write it as 2/3 times a? Because 1 times 2 is 2, isn't it?
Yes.
So 2/3 times a. Plus, how much is 1/3 times 6?
2.
2, correct. So can you tell me again, is there any like term?
So it would be -2/3a and 2/3a.
So how much will it be?
Um, I would be I would be adding, right?
Yes, negative 2/3a plus 2/3a.
That would be like 0.
Exactly. It is same, it's as if you're having -2 plus 2. So it's 0. You're having negative 5/6 plus 5/6. It's 0 because you're having same numbers with different signs. So that's canceled. That's 0. So negative 2/3a plus 2/3a, that's 0. So we don't need to write it. So it'll be a squared. And then we're having -2 and +2. How much is that?
0.
0. So it's just a squared. And that is the answer. Which option?
A.
Correct. Are you following it? Like, is it clear?
Yes. Yes.
Beautiful. So we did question number 1. Now, can you try question number 5 right now?
Okay. Can I get a second to solve it?
Yeah.
Would the answer be A?
Question number 5. A, I will check it. Question number 5, right? So I'm not sure. Should I try to do it again?
Yes.
Okay. So we'll go in parentheses and then we can go inside parentheses. So we'll solve it inside. So 3 times 6a minus 3 times 1 is how much? Minus 3 times 1.
Wouldn't that be 18A minus 3?
18a minus 3. Oh, you're multiplying 3 first, right?
Yes.
But in case of PEMDAS, what we have to do is we have to go in parentheses, and then if there is a parenthesis inside the parenthesis, we have to solve it first, right?
Right.
So there's a parenthesis, there's a bracket, there is inside the big brackets, which are outside, there are inside brackets, inside parentheses, 1 minus a and a plus 1. So we have to solve them first, isn't it?
Yes.
So that's why we'll solve inside as compared to solving them outside. Otherwise, we can do that. We can do 3 times 6a will be 18a, and we can do 3 times negative 3 will be negative 9 times 1 minus a, and then 3 times negative 5 will be negative 15 times a plus 1. That is also correct. That is also correct. If you have done in that way, we can do that. 3 times 6a will be 18a, and 3 times negative 3 will be negative 9 times 1 minus a, and 3 times negative 5 will be negative 15 times a plus 1. Is this what you got?
Yes.
Right, that is right. So 18a, and then negative 9 times 1 is how much?
Negative 9.
Negative 9, and then negative 9 times negative a.
Wouldn't that be... You said negative 9 times A? Negative A?
It's negative a, yeah, it's negative a.
Wouldn't that be 9A?
Correct. Positive 9a. And then negative 15 times a.
Equals negative 15A.
Correct. And negative 15 times 1.
Negative 14?
Negative 15 times 1, right?
Oh, okay.
So how much will
Yeah.
it be? Negative 15. So any like term?
18a and 9a.
And what about negative 15a?
Yes, that too.
So 18 plus 9 minus 15, how much is that?
12.
12a. And negative 9 minus 15.
Negative 24.
What was your answer?
My answer was A.
That's right. You're correct. I don't know what I was seeing, which key I was seeing. Answer question number 5. It's A. Well, I don't know what I'm seeing. So that's correct. 12a minus 24. That's 100% right. Now let's move one more question. Or should you try to do it as a homework?
Yeah, I could do it for homework.
Beautiful. So that'll be except question number 5 and 1. Others will be as homework, and we can start with the numbers, I think. Yeah, correct. So obviously you might have heard about different types of numbers, as the first generation of numbers comes, which was as simple. Like, for example, you're buying some bananas, you're buying some oranges, you're buying some clothes. So you say to them, like, give me 2, give me 5, give me 7. There are 150, there are 20. So these numbers are naturally occurring numbers. So that's why we say them, they are natural numbers starting from 1. Because we don't say to the to any grocery store that give me zero chocolates. So we don't use 0 in natural numbers. So that's why it starts from 1, and it's a complete number. We don't say to anyone that I'm having 2.5 children. It's not possible. It's like either 2 or 3, isn't it?
Yes.
So that's why we use natural numbers, which are complete, which are not in decimals, which are not in fractions. So starting from 1 and then continue. So that's why they are natural numbers. But when you say completeness, then 0 is also giving you some idea. So that's why the second generation of numbers is whole numbers, in which you're having 0 also included with natural numbers. 0 and all natural numbers is whole numbers. So doesn't that mean all natural numbers are whole numbers?
Yes.
So I will say one statement, tell me whether it's true or false. All whole numbers are natural numbers.
True.
Why?
Because whole numbers include natural numbers, right?
Yeah, but listen to me. All whole numbers are natural numbers.
Yes.
So that means 0 is also a natural number?
Yes?
No, 0 is not a natural number. 0 is a whole number. Natural number starts from 1. Okay. Natural number start from 1 and then they go on. But whole numbers start from 0 and then they go on. Are you following?
Yes, I was just writing it down.
Okay, so natural numbers 1, 2, 3, 4, and so on, they are all included in whole numbers. So I can say that all natural numbers are whole numbers. That is okay, but I cannot say all whole numbers are natural numbers, because 0 is a whole number and that is not a natural number. Any confusion?
No.
Okay, now comes the third degree of numbers, in which we are having all the whole numbers, but their negative counterparts also, right? Because we needed that. We needed the negative numbers. For example, if you are on the boat and you want to go up, you can say that I'll move up 5 units plus 5. But what about when you're going down the boat, when you're diving? So at that moment, we needed some negative numbers. We can say that, I'm moving -5 meters. That means obviously you're going down 5 meters. So that's why we needed negative numbers. So that's why we extended whole numbers, 0, 1, 2, 3, 4. We extended them to the left, -1, -2, -3, and so on. So all these numbers which are complete, which are not in decimals, which are not in between like 2, 3, 3, 4, 4, 5. So all those numbers, including their negative counterparts, they are called integers. So can I say all whole numbers are integers? Can I say that?
Yes.
Can I say, okay, that's right. Can I say all integers are whole numbers?
Yes.
All? Can you focus on my statement?
Except fractions and decimals.
But obviously in integers we don't have fractions, and in integers we don't have decimals. All integers whole numbers? Are all integers whole numbers?
Yes.
What about -1? It's an integer, right?
Yes.
Is it a whole number? Whole numbers start from?
No. It starts from 0.
Yeah, it starts from 0 and then it moves to the right. So -1 is an integer, but it's not a whole number, right?
Right.
So what about my statement again? Are all integers whole numbers?
No.
No, that is right, because integers contain negative numbers also. Whole numbers don't contain negative numbers. So that's why we cannot say all integers are whole numbers. But what about whether can we say all whole numbers are integers? Are all whole numbers integers?
Yes.
Yes, because whole numbers start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. They are already included in integers, 0, 1, 2, 3, 4, 5, 6, 7, and so on. So this is up to integers, and now we're having the most important numbers, which will be, which are asked in exams, and that is rational numbers. And rational numbers include all the integers, and some type of decimals, and I will tell you what type of decimals they include. Um, let's try to analyze what different types of decimals can be. Can you tell me the number which is in between 2 and 3?
2.3.
2 point?
2.5.
Yes, right, correct. So 2.5 is in between 2 and 3. Is 2.5 a natural number?
I think so.
So natural numbers are complete
Wait,
numbers.
yes, it's not.
It's not, because natural numbers don't contain any decimals, right? They are complete numbers. They are not in between those complete numbers. So 2.5 is in between 2 and 3. So it's not a natural number. Is 2.5 a whole number?
No.
No. Is 2.5 an integer?
No.
No, it's not an integer, because integers are also complete numbers. 1, 2, 3, 4, -1, -2, -3, -4. That means 2.5 is something else. It is a decimal, right? It is having some value after the decimal point. It's having 5 after decimal point. It's 2.5. It is a decimal, right?
Right.
But it is that decimal that it after 5 it stops. There's nothing else after 5. We can have one more decimal. It's 2.555. After dot, after decimal, there are 3 numbers, 5, 5, and 5. It is also a decimal. There's one more decimal that it is 2.5555555, and so on. This 5 is unending. It is also a decimal, but it's non-terminating. It's not terminating. The first example, it is terminating. It is also, second one is also terminating. But the third one, it is a decimal, but it is non-terminating, right?
Right.
And we're having one more type of decimal that can be like 2.5123719822289. Random numbers after the decimal, but not getting stopped. It is non-terminating, obviously, but there's not any number after the decimal which is recurring. There's no number. It is just the random. It's non-recurring. Are you following?
Yes.
So we got different types of decimals. One is which is terminating, 2.5, it's terminating. Second is it's also terminating, 2.555, but it's having few more numbers. It can be 575, it can be 5785, 575321. It's stopping. It is terminating also. It can be 2.5555555. There's a number which is getting repeated continuously. It's non-terminating, but it's recurring, right?
Right.
And the fourth case is it's non-terminating, non-recurring. It's a random number after the decimal, right?
Right.
So what do we say? What type of decimal will be a rational number? Now I'm going to that. Rational number. That student who is completing the homework, following the rules and regulations, and just moving to moving according to the schedule, we call that a responsible student. But that student who is just random, sometimes goes to school, sometimes does not go to school, sometimes is on the schedule, sometimes is not, just randomly doing the things. So we call that student as irresponsible student. Irresponsible. That's a responsible one. It's an irresponsible one. In the same way, we're having numbers. There's a number which is, following some rules and regulations, just, moving according to schedule. We call that as rational. In the same way, we call the student as responsible. And there are certain numbers, they are just random. They don't follow any rules. They don't move according to the schedule. Then they are irresponsible. I mean to say, they are irrational numbers. So 2.5, it is terminating, it stops, it's not having any randomness. So we call this type of decimal a rational number. Second one, 2.575321, it also stops. It's not having any randomness. So we call this number also a rational number. Third number, which is non-terminating and recurring. It is having a schedule. It's following the schedule continuously. There are numbers. They are, they are repeating 5555555. Or we can say that 2.57575757, and this 57 is getting repeated. It's not having any randomness. It's having some rules and regulations to follow. So this number is also a rational number. And the fourth one, which is random, which is not having any type of rule and regulation, just no schedule, nothing, going on, at his own pace, not following any number, not having any repetitive number. That number is not a rational number. It is irrational number. It is irresponsible number. So first, three types of decimal numbers are rational numbers. And the fourth one is irrational numbers. So in general, what we can say that decimal which is terminating is a rational number. As simple as that. That decimal which is terminating is a rational number. But that decimal which is non-terminating, but it should be recurring, is also a rational number. That decimal which is non-terminating, it's not terminating, but it is recurring. It is following some number. It's just having some numbers they're repeating. So that is also a rational number. But any number which is non-terminating, it is not getting stopped, and it's non-recurring, it's not having any number which is repeating, that number is not a rational number. That is called an irrational number. Did you got that?
Yes.
Can you make me understand quickly what type of number is rational and what is irrational?
Okay, so these numbers can be like put into fractions.
Yes, that is what I was gonna do after this. But you have told me before, but I don't want that right now. I just want in decimals. Like in decimals, what can you say about rational numbers? Which decimal is a rational number?
Like, give you an example.
No, you're having example in between, in front, or you can give an example.
So 6.48 is a
Yes.
rational number.
Yes. Why? What's
It
the
could be
reason?
written as a fraction.
Correct. That is the second part of it. That is the second thing which we're going to discuss. But if you're having any decimal number, how can you recognize whether it is a rational number or not? You will see whether it is terminating or not. If it is terminating, for example, 6.48, it's terminating. It's not moving after 48. So it is a rational number. And if you're having a decimal number which is non-terminating, but it's recurring, 2.375375, and this 375 is getting repeated. So we can say that this is also a rational number because it is non-terminating and recurring. But what about 2.17291823357, and there is randomness here? Do we say this is a rational number?
That's irrational.
That's irrational number, correct. Now, what is the quality of those decimal numbers which we have discussed? Terminating and non-terminating and recurring. Two types of decimal numbers are rational numbers. One is terminating, and the second one is non-terminating but recurring. So these two types of decimal numbers are rational numbers. Why? What is the quality in them? The quality is what you said, that these numbers can be represented in the form of P by Q, in the form of a fraction. They can be written as fraction. They can be written as, some integer divided by some other integer. So they are having this type of quality. But this irrational number, which is having randomness, it cannot be expressed in fraction. As simple as that. Irrational numbers cannot be expressed in fractions. No way possible. Irrational numbers cannot be expressed as fractions. So, but P and Q, which is the numerator and the denominator of a rational number, they should be integers, complete numbers. And Q cannot be zero. Q cannot be zero. So I'll give just one or two numbers and then we can stop, and you tell me what is that type of number. We're having 3.57328. Is it a natural number? Yes, Madison?
No.
No. Is it a whole number?
No.
Is it an integer?
No.
Is it a rational number?
No.
Why?
Because it can't be written as a fraction.
How do you know that?
Because it isn't.
It is in decimal, right?
Yeah.
Okay, but I have told you which decimal numbers can be represented in fractions. Which decimal numbers can be represented in fractions?
Rational.
Yeah, but like in terms of terminating, non-terminating, recurring, non-recurring. I'll tell this again because see, we're having a decimal number, for example, 2.5. This can be expressed in fractions, 25 by 10 or 5 by 2. And we don't need to even express this in fractions to know whether it is a rational number or not, because we can know that by simply seeing what type of decimal this is. If this is terminating means it is getting stopped, it's not continuous, then it is a rational number. As simple as that. Don't confuse yourself with the definition which might be in the school or somewhere. Whatever the decimal is, if that is terminating, if that is stopping, then that is a rational number. As simple as that. Whether it'll be, 100 numbers after a decimal. For example, 2.32987162118. It stops. It's not having 3 dots. It stops there. It is also a rational number because it's terminating. Can you repeat what I said?
It's not rational because it's terminating?
No, it is rational. It is rational because it is terminating.
Oh, I thought you just said it's not rational.
No. It is rational because it is terminating. And we can express this in the form of P by Q. But we don't need to express it. We just want to know whether it is rational or not. We have to simply say, if this is terminating, then it is a rational number. Okay?
Okay.
If this is terminating, yeah.
So like 2.3298 and something else would be terminating, right?
Terminating means it is stopping. So 2.3298, if this is stopping there only, it's not continuously moving, then this is terminating, it's stopping. There's no number after 8. There's nothing after 8. So that's why we can say it is a rational number. It is a rational number because it is stopping, it's terminating, it's not moving. Are you following what is terminating?
Yes.
So what about 2.2298765? Is it terminating or non-terminating?
It's terminating.
If it is terminating, is it rational or irrational?
Rational.
Correct. All the terminating numbers are rational. As simple as that. All the terminating numbers are rational. Got it?
Yes.
What about 3.57328? Is it terminating or non-terminating?
Terminating.
Is it rational or irrational?
Rational.
Correct, because it's terminating. As simple as that. Right?
Yes.
What about this number? 4.193193193 and so on. This 193 is getting repeated. That's why I'm putting a bar on 193. Is it terminating or non-terminating?
Non-terminating.
But is it recurring or non-recurring?
Recurring.
Recurring. So those numbers which are terminating, which are non-terminating, but they are recurring, they are also rational numbers. Are you following?
Yes.
Those numbers which are non-terminating like this, 4.193, 193, 193, and so on, but they are recurring, they are also rational numbers. They can also be expressed in the form of P by Q. We don't need to express it right now, but still they can be expressed. And how do we know that? Because they are decimals, they are non-terminating and recurring. So 4.193, 193, 193, and so on is a non-terminating decimal, but it is recurring. That's why we can say it is a rational number. What about 2.1967, 1967, 1967, and so on? 1967 is repeating.
It's non-terminating.
It is non-terminating, yeah. And is it recurring or non-recurring?
It's recurring.
So if the decimal is non-terminating and recurring, is it irrational or irrational?
Irrational.
No, it is rational. That's what I was saying you. It is a rational number. Are you following? It is a rational number. All terminating decimals are rational numbers. It is clear. But all non-terminating numbers, they can be categorized into two parts, recurring and non-recurring. If non-terminating numbers are recurring, then they are rational numbers. If they are recurring, then they are rational numbers. Recurring, rational. If they are recurring, they are rational. They are rational. 2.19, there's a bar on 19. That means it is 2.19191919. So it is obviously non-terminating, but it is recurring. So if it is recurring, then it is a rational number. It is a rational number. Right?
Right.
Can you tell me about this 3.23 and there's a bar on it? Is it rational or irrational? I have taken more time, but this concept needs to be clear. Because I cannot like stop it in between because it might get disturbed in the mind. 3.23. Is it recurring or non-recurring?
It's recurring.
So all recurring numbers are rational numbers. So is it irrational or irrational?
Rational.
Right. That is what I was saying. Last one. 1.91236785. There are three dots. It's continuous. The numbers are random. There's no number which is repeating. So I can say that it is obviously non-terminating. But is it recurring or non-recurring?
Non-recurring.
Non-recurring. If it is non-recurring, then is it irrational or irrational?
Irrational.
Irrational, exactly. That is it. That is it. Now you got it. Because one more thing, this cannot be expressed in the form of P by Q where P and Q are integers. It cannot be expressed. Others can be expressed. Just one example. What about 1.732198631 and there are three dots. Three dots means it's continuous. The numbers are random, continuously moving. So which type of decimal is this?
It's non-recurring.
Non-recurring. So if it is non-recurring, is it a rational or irrational?
Irrational.
Irrational, correct. What about 2.1? Is it rational or irrational?
It's rational.
Why?
Because it's terminating.
Correct. That's it. So we'll stop here. And you just have to, 1 second. So this was rational, irrational. And then we need to do a little more. Okay, so the questions which I have given you, they are on the top on page number 10. Page number 10, you have to do the questions. And just try to see page number 12, the questions of page number 12. If you're not able to get them, no problem, we can do them, but just try to see them and see whether you'll be able to do them by the calculator and see like whether you're able to understand them or not. So page number 12 and page number 10, you try as homework.
Like the full page?
Try to see the full page, yeah, because we're having good time. We're having maybe for like 5-6 days. Okay.
And how will I access this?
You're already having this thing in the Fiverr, this book. So Or else I can email it to you if you want to.
I can't get any link because I can't sign in.
Uh, okay. So on which email should I send it to you?
Are you gonna send me screenshots of it?
No, I'll just send the book directly. The PDF.
Wait, is this from the book that my father has?
Yes, exactly. It's the same book.
So shouldn't he be able to access this?
Obviously, yeah.
Okay, what chapter is this?
This is chapter 1, page number 10 and 12. Okay, page number
Okay, I
10.
got it.
Yeah, great. So 10 and 12 you try, and we'll see how much you had done in the next session. Any questions for today?
Pardon me?
Any questions for today? Like any confusion, any question
No,
for me?
no.
Okay, okay then. Thank you. Thank you very much.
My aunt would like to speak to you.
Yeah, sure.
Okay.
Hello.
Hello, how are you?
I'm doing well, thank you. The link that you have for the Google, the
Microsoft
Microsoft
whiteboard.
whiteboard,
Yeah.
I even tried to access it from my own Hotmail account, and I had that account since I was like 16. It's stating that I have no permission and that the tenant needs to add me in order to access the whiteboard. And it was the same for Madison and the same for her father. So we all tried unsuccessfully.
This thing happened to me also, like coincidentally, but what I did is I just tried to install it in some different, methods. Like I installed it like using different website, or opening it, just logging out from my account and then installing it. You know, I tried this way, and then I was able to open it. So
Okay.
what I can suggest is like try to log out from the accounts which you're having, and then try to get it from the Microsoft Whiteboard website. And when it asks for the login, then at that time, if you log in, then I think it might work. I'm
Okay,
not.
so we'll try that
Yeah.
tomorrow. We'll definitely try it, and I'll have her dad just shoot you an email to let you know if we were successful.
Okay, fine. If not, then we can connect with the TeamViewer, the software by which I will be able to see your screen, and maybe I'll try to help in that solution, right? Maybe.
Okay, not a problem. Thank
Okay.
you.
Thank you very much, because this
Okay.
is a possibility. Like you can definitely go there, because this has happened to me also in the start. I was not able to do that maybe for a few days, but I just tried and tried and tried. I got the way, and this thing happened. So definitely you'll be also you will be definitely getting some way to do it. And then
Okay.
after that, it has never happened to me again.
Okay,
So
that's great.
yeah, thank you very much.
Okay, hold up for Madison. 1 second.
Yep. Yep.
Okay, hello.
Yeah, hello, Madison. So we'll stop here, and you will try these questions, and we'll meet next Thursday, right?
Next Thursday, yes.
Okay, fine. So any questions for today? Any confusion for today?
No,
Anything you want to ask?
no.
Okay, then. Thank you. Have a good night. Bye-bye.
Have a good day.
Thank you. Bye.
Bye.